In the last video, we introduced logarithmic functions. So let's recall that if you have a function f of x equals b to the x, where b is positive and not equal to 1, then we define the function g of x, which is log sub b of x. And what it does is it undoes what the function f does. And one way of saying this is that the functions f and g are inverses of each other. There's a general concept of the inverse of a function, which in this video we won't get into. But what it means is that f of g of x equals x. So if you plug in x into the function g, okay, you get g of x. Then when you plug that into your f, you get x. So the original input. And it also means that g of f of x equals x. So this is for all x in the domain. So for f of g of x equals x, this is for all x in the domain of g, which is all real numbers. And then, sorry, it's all positive numbers, because you can't have log sub b of a negative number. So this is the first one is when x is positive. And then for g of f of x equals x, we're looking at the domain of f of x equals b to the x, and that's all real numbers. Well, what do you get when you write it out? F of g of x equals x means, well, g of x is log sub b of x, and f of x is, so this is saying that f of g of x is log sub b of x. This is equal to x. So f of log sub b of x, well, f was b to the x. So this means that b to the log b of x power is equal to x. Let's put that in the box. So this is for all positive numbers x. And if we write out what g of f of x equals x tells us, g of, so f of x is b to the x. So g of b to the x equals x. G is the log sub b function. So when you plug in the log sub, when you plug in b to the x into the log sub b function, you get x. So this is what we've seen before. Log sub b of b to the x powered is x, but this is for all real numbers x. Okay. So for instance, if you had log sub 1254739 of 1254739 to the power of like 6,512, okay, this would be, you don't have to figure out what this number is. You just know that the answer is going to be 6,512, so you don't need to know what that number is. You just know that the answer is 6,512. The log sub this number of that number raised to 6512 is 6512, using this property. Log sub b of b to the x is just x. And similarly, if I had 12579 raised to the log sub 12579 of 86, this is just equal to 86 because I'm using this property here. that b to the log sub b of x is just x. Okay. So what is log sub 8 of 8 squared? That's 2. What is, okay, how about 3 to the log sub 3 of 2? Well, that is also 2, right? Because we're using the property b to the log sub b of x is x. So our b is 3 in this case, and our x is 2. What if you had 3 to the 4 log sub 3 of 2? Well, here we can use our exponent facts, that if you have a to the mn power, right, so the power is m times n, this can be thought of as a to the m raised to the nth power, but it's also equal to a to the n raised to the m power. And in this case, it's easier to rewrite it as 3 to the log sub 3 of 2 raised to the 4th power. I mean, we could try 3 to the 4th power raised to the log sub 3 of 2, but that wouldn't, I mean, that's correct, but it wouldn't get us anywhere, because 3 to the 4th power is 81. 81 to the log sub 3 of 2, I mean, what is that? We don't know. Right? It's not helpful, even though it's correct. So this is correct, but not helpful. Instead, we want this one, 3 to the log sub 3 of 2 raised to the 4th power, because we know what 3 to the log sub 3 of 2 is, that's 2, and then 2 to the 4th power is 16. So the answer is 16. So this is an important thing to be able to recognize. So if you have a to the, like, c times log sub a of b, okay, this is equal to a to the log sub a of b raised to the c power, and then a to the log sub a of b is just b, and then b to the c power is just b to the c power. So I wouldn't memorize, that when you have this is equal to the b to the c power, but you should remember the technique of going here and then going there. Okay. How about log sub 10 of 0.001 cubed? Again, let's try doing this without figuring out 0.001 cubed. So what I want to do is I want to rewrite this as, I want to rewrite 0.001 cubed as 10 raised to a power, because then I can use my log property. Well, so let's do that on the side. So 0.001, that's 10 raised to what power? Let's see. Isn't it negative 3? Because 0.001 is 1 over 1,000, right? So it's 10 to negative 3. Or you could say that you have to move the decimal point. So if you start off with 1.0, you have to move the decimal point 3 places to the left, and then get 10 to negative 3. But I think it's just easier to convert to a fraction, because then you can be more sure that it's correct. So anyway, so 10 to negative 3, and then I have that cubed, right? So I really have log sub 10 of 10 to negative 3 cubed. So I have to do 10 to negative 3 cubed is what? Is 10 raised to what power? Negative 9, right? You multiply the exponents, not add them. Add them would be 10 to negative 3, times 10 to negative 3. That would be 10 to negative 6. This is, you're cubing 10 to negative 3. Okay, so now we have log sub 10 of 10 to the negative 9, and that is equal to, what's the answer? Negative 9. How about log sub 1/2 of log sub 2 of 16? We'll take a moment and try to figure out what this is. Okay, well first we need to figure out what log sub 2 of 16 is, and then we need to figure out what log sub 1/2 of that is. So log sub 2 of 16 is 4, because 2 to the 4th power is 16. Now we have to figure out what log sub 1/2 to the 4th power is. So again, remember if you have something like this and you want to think about it in terms of exponents, it's always a good idea to just call this number x and then rewrite it as an exponent equation. So 1/2 raised to the x power is 4. And there are a couple ways of thinking about this. I know that 1/2 squared is 1/4. And I know that 1/4 raised to negative 1 power is 4. So if I take 1/2 and raise it to the negative 2 power, that would be squaring it and then raising it to the minus 1 power, so I get 4. So the answer is negative 2. How about, let's think about a general property. What if I had log sub 3 of 9 to the 8th power? All right, let's call this x, right? So 3 to the x power is 9 to the 8th power. And now what are we going to do? We're going to rewrite it in terms of a common base. So 9 is 3 squared, and then you have that raised to the 8th power. So 3 to the x is 3 to the 2 times 8. That tells us that x is 2 times 8, which is 16. Let's think about this more generally. What if I had log sub 3 of a to the b power? So what is this in terms of log sub 3 of a? It turns out there's a relationship, and let's see if we can figure out what it is. Well, let's call log sub 3 of a to the b y, and log sub 3 of a equal to x. So we want to figure out how is y related to x. Or if you want, let's call this like z and w or something. If you maybe instead of using these letters, we'll just call this z and let's call this w. Okay. So how do we write z equals log sub 3 of a to the b in terms of exponents? This means that 3 to the z power is a to the b power. And what does w equals log sub 3 of a tell you? This means that 3 to the w power is a. Okay. So I know that 3 to the w power is a, 3 to the z equals a to the b. What can I do to this equation, 3 to the w power equals a, to get an a to the b power? So I'm trying to compare z and w, right? So I'm trying to compare 3 to the w equals a and 3 to the z equals a to the b to relate z and w. So I want to try to get these equations to match up somehow. So if I take this equation 3 to the w equals a, what can I do to both sides to get a to the b on the right I can raise it to the b power. So 3 to the w raised to the b power equals a to the b. Well, 3 to the w raised to the b power simplifies as 3 to the wb. So 3 to the wb is a to the b. Now a to the b, we just saw, is 3 to the z. So what that tells you is that w times b equals z. Right? Because if you have 3 raised to the power equals 3 raised to the power, those powers must be the same. Now let's go back. So we've just discovered that w times b equals z. Let's go back and remind ourselves what w and z were. W was log sub 3 of a. Okay, so w times b, let's put the b out on the left, equals z, and z was log sub 3 of a to the b. So that's the connection between log sub 3 of a to the b and log sub 3 of a, that it's log sub 3 of a to the b is equal to b times log sub 3 of a. And if you think about it, there was nothing special about 3, right, this base. So in general, if you apply the same reasoning, if you have log sub c of a to the b power, that is equal to b times log sub c of a. That's an important property. So for example, log sub 5 of x to the 7th power is equal to, so my c is equal to 5 in this case, my a is equal to x, and my b is equal to 7. So if I just write down what the equation says, I get 7 times log sub 5 of x. Here's another example. What's log sub 5 of 25 to the 36th power? Well, I'm using my property of logarithms. This is 36 times log sub 5 of 25. And I know what log sub 5 of 25 is. What is that? That's 2, because 5 squared is 25, and then 36 times 2 is 72. So notice that this answers that question that we did before a lot faster. So going back to what we did here, we called it x, and then we wrote things in terms of a common base. That's fine, that got us the correct answer, but let's try doing this problem again using the property. Log sub 3 of 9 to the 8th power, we know that we can bring the 8 down, so it's 8 times log sub 3 of 9. Log sub 3 of 9 is 2, so 8 times 2, you get 16. Okay. What's log sub 5 of log sub 8 of 512 to the 4th power? So by our property of logs, why don't you try figuring it out first, and then we'll go over it. Okay, let's go over it. So by the property of logarithms, it's 4 times log sub 8 of 512. And we can actually do this. Log sub 8 of 512 turns out to be 3. Is that right? Yeah. So it's 4 times 3, so the answer is 12. And let's just remind ourselves that this works even if your numbers are not integers, right? So log sub square root of 2 of square root of 2 to the pi, okay, is equal to pi. So that's an important property of natural logs. Another important property of natural logs is that it converts the products to sums. So if you have log sub b of x times y, this is equal to log sub b of x plus log sub b of y, if x and y are positive. Notice that if x and y were not both positive, it wouldn't make sense to talk about log sub b of x. Okay. So why is this true? Well, we know that when x and y are positive numbers, it's always b raised to some power. Like you will always be able to, if b is any positive number, okay, the range of the function b to the x is all positive numbers. So any positive number is b raised to something. So we can write, say x is equal to b to the u for some number u. And y is equal to b to the v for some number v. Well, then the left-hand side, log sub b of x times y, that's log sub b of b to the u times b to the v. And now how can I rewrite the inside? How do I simplify b to the u times b to the v? It's b to the u plus v power. And log sub b of b to the u plus v is what? U plus v. Right? By the property of the log sub b function as the inverse of b to the x power. So the left-hand side is u plus v. And we're trying to show that this log sub b of x times y, the left-hand side, is equal to the right-hand side. So we should show that the right-hand side is also equal to u plus v. Well, you can probably see where this is going. Log sub b of x is log sub b of b to the u, so that's u. And log sub b of y is log sub b of b to the v, and that's v. So log sub b of x is u, log sub b of y is v. So then the right-hand side is just u plus v. And we already found that the left-hand side is u plus v. Therefore, they're the same. Right? And that is the explanation of why this is true. So log sub b of xy equals log sub b of x plus log sub b of y. So for instance, if I had something like log sub 2 of, I don't know, 7 times 2 to the 10th power, I can split this up as log sub 2 of 7 plus log sub 2 of 2 to the 10th power, and then that's going to be log sub 2 of 7 plus 10. But an important thing to note is that log sub b of x plus y, this does not split up. So when you have a sum and you're doing log sub b of it, that doesn't split up. But if you have a product, so this is a product, x times y, the result of applying log sub b of it is the log sub b of each of those, each of the factors added together. Okay, so let's just review some of the properties, since I've already written them down. Let's just kind of review them. So the fact that b to the x and logs of b of x are inverses tells us that you have b to the log x is x, b to the logs of b of x is x, for all positive numbers x, and logs of b of b to the x is x. Okay? That's just from the fact that they're inverse functions. They're inverses of each other. They undo each other. And then another property is this property, that log, so if you have base c, log of a to the b is b log a. So you can move the b down, the exponent down. That's an important property. And this product to sum property of logs, that log of xy is equal to log x plus log y, no matter what your base is. So those are the important properties of logarithms to know, and most of the algebra that involves logarithms really just boils down to applying these properties.